to our last installment of the stoichiometry guided notes videos. This is the hardest part, right? Previously, we were talking about mole to mole stoichiometry and mole ratios and what stoichiometry really is. But this is probably the most practical part of stoichiometry, where we start with a known mass of a substance in our equation, in our chemical equation, and then we find a mass that we're looking for, right? Because mass is the quantity that we will make sense of the most. We know what 5 grams may look like or feel like. We can sense these numbers. So mass is the most practical unit for us to work in as people. So it makes sense that we need to know how to convert between grams of something and grams of something else within stoichiometry. So here we go. By the way, this is the part where if any of you have talked to me about, well, I like to do the unit conversions between grams and moles a certain way, this is what I was talking about when I said we need to do it this way, right? Where we have all the fractions lined up in a nice neat line and setting it all up together, because we're going to have a lot of fractions to set up here. But if you are careful with how you set it up, it's all going to work out. So here we go. We have our chemical equation right here. 3 moles of aluminum and 3 moles of ammonium perchlorate react to form 1 mole of aluminum oxide, 1 mole of aluminum chloride, 3 moles of nitrogen monoxide, and 6 moles of water. And now we're going to do some stoichiometric math. Assume you completely react 10 grams of ammonium perchlorate with excess aluminum, meaning we have an infinite amount of it. Anytime you see excess, that's meaning we're never going to run out of it, so don't even worry about it. We are going to completely react 10 grams of ammonium perchlorate. How much nitrogen monoxide is produced? What mass of nitrogen monoxide is produced? So we're looking for grams here. But the steps that are involved, you can never just go from grams of one thing to grams of something else. So grams of substance A to grams of substance B. We can't do that because grams of this thing and grams of that thing are not equal in terms of how many particles are present. Instead, we need to take a quick step at moles. So we have grams of A, we convert that to moles of A, then we convert that to moles of B, just like you saw in the previous video, and then we can convert it finally to grams of B, the thing that we're looking for. So that's our process here, and that will always be the same. Wherever you start along this process may be different. I could start here, or I could start here, depending on what the question gives me. In this particular case, I am given 10 grams of my one reactant, and I am looking for the grams of the other product. So I have to go through moles to get there. So let's do it. Start with what we know, 10 grams of ammonium perchlorate, NH4ClO4. Okay, set that over 1. Great. Before we do anything, we're going to need to get the molar mass of ammonium perchlorate, which nitrogen is 14.01 grams per mole. Hydrogen is 1.01 grams per mole. Chlorine is 35.45 grams per mole, and oxygen is 16 grams per mole. Just again, all of those values are coming from the periodic table. Now, I have 1 of these, 4 of these, 1 of these, and 4 of these in my formula to give me a grand total of 14.01 times 1 plus 1.01 times 4 plus 35.45 times 1 plus 16 times 4 gives me 117.5 grams per mole of ammonium perchlorate, NH4ClO4. Okay, very good. All right. Now, with that number, I can find the molar mass. I want to go back to this little flow chart that I have here for you. The units at each of these steps tell you the units that will go in each of these numerators in order. In this case, substance A is what we know. Substance A in this case is ammonium perchlorate. So I have to go from grams to moles. So I can set the next numerator to be moles of ammonium perchlorate, NH4ClO4. I need to extend that bar. Good. For every 1 mole of ammonium perchlorate, I have 117.5 grams of ammonium perchlorate. Right? And that's what we found here with the molar mass. Now that I have moles of ammonium perchlorate, I can convert to moles of what I'm looking for, and that is going to be nitrogen monoxide. So I'll set my new fraction up. Moles of NO, and I know I'm going to need to expand that. Moles of NH4 ClO4. Why did I put this on the bottom? It's because it will guarantee to cancel out with the moles of ammonium perchlorate in the numerator of the previous term. So what are the numbers going to be here for this fraction? Moles of this and moles of that? They come from our balanced chemical equation, and this is the number one rule with stoichiometry. You have to make sure that your equation is balanced, otherwise this will not work. So for every 3 moles of nitrogen monoxide that we make, we use 3 moles of ammonium perchlorate. How neat is that? And my final term, if I started with grams of A, converted to moles of A, and then converted to moles of B, I'm going to end with grams of B. So my ending term here will be grams of NO, and thus I can follow my units. Moles of NO are here. They have to be the denominator of the next term as well. For every 1 mole of nitrogen monoxide, how many grams is that? Well, again, nitrogen, 14.01 grams per mole. There's 1 of those. Oxygen is 16 grams per mole. There's 1 of those. Add those 2 values together, you get 30.01 grams per mole of NO. So I can put 30.01 right here. And now that I have all of that set up, I know it's a lot to set up, but we can put it all together here and now and actually do this math. And I'm going to show you the calculator as I go through this as well, just so we can be very clear on how I'm operating these numbers. If you're the type of person who likes to multiply all the numbers across the top and get an answer, multiply all the numbers across the bottom and get an answer, and then simplify that final fraction, you are welcome to do so. Order of operations is true no matter which way you're going to do it here, just as long as you don't multiply when you're supposed to divide and vice versa. I personally like to multiply by each number across the top. 10 times 1 times 3 times 30.01 equals, I see my calculators in scientific notation, so that is 900.3. And then I will divide by each number on the bottom. So divided by 1 equals, divided by 117.5 equals, divided by 3 equals, and then for funsies, divided by 1. So 2.55 times 10 to the 0 power is just 2.55. Which this means 2.55 what? Chickens? No. Grams of ammonium perchlorate cancel out. Moles of ammonium perchlorate cancel out. Moles of nitrogen monoxide cancel out. The only thing that doesn't is the unit that we are looking for, and that is grams of nitrogen monoxide. Now, what does this answer mean? You've seen all these videos so far. Got to get used to thinking about this. What does this calculation say? For every 10 grams of ammonium perchlorate I react in this equation, I will make 2.55 grams of nitrogen monoxide. That is what the calculation says. Get in the habit of thinking about what your math is saying, and it'll make the math make more sense. Okay? So, here we go. Let's move on to these next few examples here. So, you produce 12 grams of water. What mass of aluminum did you use? All right, same exact equation above. So we're going to use this equation right here to help us figure this out. You produced 12 grams of water. What mass of aluminum did you use? Notice, we know the mass of the product in this case. And we're trying to figure out how much of the one reactant we use. See, water is a product and aluminum is a reactant. The math is still the same. In this case, what we know is A, right? And what we're looking for is B. So we can set up the math the exact same way. Here we go. Starting with what we know, 12.0 grams of H2O over 1 times, so we have I'm going to write this right here. Grams of A goes to moles of A, and then moles of A goes to moles of B, and then moles of B goes to grams of B. So I've got grams of water. I better have moles of water in my next numerator. And what is my unit here? The same as it's going to be in the denominator of the next term, grams of H2O. I'm actually just going to set up all of my units right now just to prove a point. Moles of A is water, and we're looking for aluminum, so moles of B will be moles of aluminum. And moles of H2O can be set up in the denominator because it was this numerator. Then, lastly, moles of aluminum will go in the denominator, and we can have grams of aluminum up top. See here, grams of A, moles of A, moles of B, grams of B. And when I finally operate all those numbers together, it will give me my answer. So, let's see here. Hydrogen is 1.01 grams per mole times 2. Oxygen is 16 grams per mole times 1. The two of them together is 18.02 grams per mole of H2O. So, for every 1 mole, 18.02 grams. And in this chemical equation, we have to use the coefficients to find the mole ratio. So, for every 6 moles of water that we make, we must use 3 moles of aluminum. So that'll be a 3 for aluminum and a 6 for H2O. And lastly, 1 mole of aluminum. I don't have a periodic table with me. How about that? Well, I'm going to have to look it up. How about that? Yeah, I think it's 26. Molar mass of aluminum. 26.98. How about that? Grams per mole. Now, when I plug in all these numbers together, I'm actually going to do it the other way this time, where I'm going to get the whole big fraction. Okay, so 12 times 1 times 3 times 26.98 is a really big number, 971.28. Again, don't round in your answer until the final answer. In the denominator, 1 times 18.02 times 6 equals 108.12. Now let's bring our units with us. You have grams of H2O times moles of H2O times moles of aluminum times grams of aluminum. In the denominator, grams of H2O times moles of H2O times moles of aluminum. We can simplify, 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 simplify. You got it, simplify. Leaving us with the units that we are looking for, 971.28 divided by our answer in the denominator is going to be 8.98 grams of aluminum. What does this answer say? If I produce 12 grams of water, I must have used 8.98 grams of aluminum. Fact. Good stuff. Let's keep going. 0.45 grams of aluminum oxide were produced. What mass of aluminum trichloride was also produced? Here we go. We're going to speed run this one. Al2O3 over 1. So I've got moles of Al2O3, moles of AlCl3, and grams of AlCl3. In the denominator, I just follow the units. Grams of Al2O3, bringing it over here, moles of Al2O3, and then moles of AlCl3. Let's see what we got. 26.98 times 2 plus 16 times 3 gives me aluminum oxide for a grand total of 1 mole, giving us 101.96 grams. In our balanced chemical equation, our coefficients for aluminum trichloride are 1 and aluminum oxide are 1. So, ratio is 1 to 1. How about that? Lastly, aluminum trichloride 26.98 plus 35.45 times 3 gives us 133.33 per mole, grams per mole. Plugging all those numbers in together, we have 0.45 times 1 times 1 times 133.33 divided by 101.96, and then divided by 1, divided by 1. We're looking at 0.588. Why did I go to 3 decimal places? Because I felt like it. I don't know. Go to 2 if you want. 0.59, 0.588. Honestly, since this is 2 significant figures here, realistically, this should actually be 0.59. So let's be scientifically precise here. Why not? And the answer is in grams of aluminum trichloride. Why? Because grams of aluminum oxide cancels, moles of aluminum oxide cancels, and moles of aluminum trichloride cancels, leaving us with the only unit that didn't cancel. And that is our answer. And look at that. Just want to make something clear. We were looking at one of our products and comparing it to another one. So if I produced this much aluminum oxide, I must have also produced this much aluminum trichloride. That's how stoichiometry works. It doesn't matter if you're comparing 2 products or 2 reactants or a reactant in a product or a product compared to a reactant. Since they're all part of the same balanced chemical equation, you can use those values any way you want. You produce 2.5 grams of nitrogen monoxide. What mass of ammonium perchlorate was used? Here we go. 2.5 grams of nitrogen monoxide over 1. Okay, we're going to convert that to moles of nitrogen monoxide. We're going to convert that to moles of a really long formula, NH4ClO4. And then we are going to convert that to grams of NH4ClO4. Hey, don't make this harder on yourselves. Write the values from the first example that we did at the top of the page. Right? We already have those numbers. We shouldn't need to calculate them again. So for every 1 mole of nitrogen monoxide, 30.01 grams. And for every 1 mole of ammonium perchlorate, 117.5 grams. Okay, and then let's look at our balanced chemical equation for our mole ratio. For every 3 moles of nitrogen monoxide that are produced, 3 moles of ammonium perchlorate must be used. So there's a 3, and there's a 3 in our mole ratio. Plug it in at 2.5 times 1 times 3 times 117.5 gives us a big number. Divided by 30.01, divided by 3, divided by 1 gives us 9. Technically 8, 9.8. If we're using significant figures, 2 significant figures here, we should have 2 in our answer as well. So I'm going to round that to 9.8 grams of ammonium perchlorate. And that's the game. Why? Because grams of nitrogen monoxide cancels, moles of nitrogen monoxide cancels, moles of ammonium perchlorate cancels, leaving you with the one unit you're looking for, grams of ammonium perchlorate. It's magic. It's magic. Now, here we go. This one is a little tricky. You got to think about limiting and excess reagents, and you'll learn about that in the next video. Ha ha ha! Don't forget to subscribe. I'll see you there.